Hello, how are we doing? So we're up to Chapter 9 of Routing and Switching Essentials, which is NAT for IPv4. Of course, NAT stands for Network Address Translation. So we'll look at how NAT provides IPv4 address scalability in small to medium-sized business networks. We'll talk about why we have NAT, how it works, and what advantages and disadvantages it has. Then we'll look at how to configure NAT, both mostly using CLI. We'll also look at doing port forwarding, both on a router, on a smaller home router, as well as on NAT, on the CLI on an iOS router. And we'll also briefly look at troubleshooting NAT. So, how does NAT operate? So, back in the early 90s, it had been noticed that the IPv4 addressing space was running short of addresses. And so, the IETF and several other organisations decided to create a plan to at least slow down that use of the address space. And so one of the solutions was to have private internet addresses. And so, of course, that's RFC 1918, as it says on the screen. And so they set aside three range of addresses, 1A, 16B and 256C class networks, so they could be used in the way anyone likes, as long as you don't connect to the internet with them, basically. So that stopped people having to register IP addresses for completely non-connected networks. They could just use one of these ranges and away they went. So, as I said, private IP addresses cannot be routed over the internet. Most, if not all, ISPs will actually have access and control list entries that will actually block source and destination IP addresses that are private. And so we use NAT to translate private internal addresses to public internet addresses that can be routed over the internet. And so one public IPv4 address can be used for thousands of devices that have private IP addresses. And so this is, as I said, one of the ways they use to conserve IP addressing space. So, what is NAT? So, as we said, private IP addresses cannot be routed over the internet. NAT is used to translate private IP addresses used inside a company to public IP addresses that can be routed over the internet. NAT hides the internal IPv4 addresses from outside networks. Companies use the same private IPv4 addresses, so outside devices can tell one company's 10 XXX from some other company's 10 XXX. And so a NAT-enabled router can be configured with a public IPv4 address, and then a NAT-enabled router can be configured with multiple public IPv4 addresses to be used in a pool, or a NAT pool, for the internal devices configured with the private IP addresses. Important concept, NAT is normally enabled on only one device, and so it will often be your border router between your organisation and the ISP. And so you may well have one or a pool of public IP addresses available, and they would normally be assigned to that router there. And of course, you would have your private IP addressing inside your network. Now, some terminology. There's four terms that are used to describe addresses when it comes to NAT. So there's inside and outside, local and global. So inside means inside your network, outside means outside of your network, and there's local and global. So local means normally the address that's directly assigned to that host, and it's normally an internal address or private address. And global means what the world sees, and so that would be what address it's translated to when when traffic goes through that NAT router. And so basically from there you can actually have inside local and inside global, and there's also outside local and outside global. Now, outside local normally is not our concern because if some company is doing their own NAT, it's actually not particularly visible to us anyway. And so when it comes to outside addresses, we normally only really care about outside global addresses. And so from this diagram here, we have an internal host with a private IP address that wishes to get to a web server outside on the internet. And so, of course, its address that it's been assigned locally is this 192.168.10.10. And so when it goes to attach to that web server, of course, it goes via its gateway because it's on a different network. And so the packet will get to this router here, and this is the router that's been set up to do the NAT translations. And so this router is the border between your inside addresses and outside addresses. And so it will have typically one outside address on its link to the ISP, and it will of course have an inside address on the interfaces that are on the internal side of the network. And so this packet, when it flows, will actually have a source address of the internal, or I suppose I should say inside local address, and then of course the destination is to the web server, so that's outside. And so it will come through the router, and the router will translate it. And so it will actually use, in this instance, it's using 209.165.200.226. And so what it has to do, it actually has to change the header, the IP header. It has to rewrite the source address to be that. And so the router needs to keep track of all the conversations that are going through the router, so that when that reply to that packet comes, it knows that, oh, this address here is actually this inside global address is actually referring to this inside local address. And so when the packet returns, of course this would end up being the destination, so it would arrive here, and then the router will look up its table. Oh, okay, that's actually for 192.168.10.10. It will actually have to rewrite the IP header again when the traffic returns. And so as you can see, there's some overhead included in that, and so the router actually has to do a bit of work. And so if you want the quickest possible transmission, NAT's not going to help with that, but anyway. And so when you have these conversations going on, you of course will actually have a table, and so an inside global address and an inside local address. And then it also keeps track of the outside local and the outside global. But as you can see, it's the same thing. So really, I normally just call it outside global. And so basically, that's the table that it records the details of the conversation in. So this is plain NAT. We will talk about PAT in the coming slides. And so, as I said, if this host wants to talk to that that web server on the outside, of course this host will put its own IP address as the source address. I'm assuming router 2 here is the one that will actually rewrite the source address to be a public routable IP address, and so that's the way it will go. And so of course it keeps track of the table, and of course the source address on the return will come back here. Oh, sorry, that's on the way out, but anyway. And so of course when the web server replies, of course the destination address is to get back to that host is this one here. It'll arrive at the router and it'll actually rewrite it to be the inside local. Now, static NAT. Now, there's several types of NAT you can run, and so static NAT assigns one public IP address to one private IP address. And so you wouldn't normally do that for every host out there. You would normally do it for a server. And so you commonly use for servers that need to be accessed by external devices or for devices that must be accessible by authorized personnel when off-site. Sorry. So there's a one-to-one address mapping between local and global addresses. So we haven't actually saved a lot of addresses here, but yeah, we've got this internal server that is accessible from the rest of the world. And so this server, of course, could be running multiple services that are accessible from the outside world. So we're showing SSH here, so that must be someone from home who's able to log in and maybe administer the server, or maybe an external company, I suppose. Of course, you know, it could be a web server, it might be a mail server, or whatever it might be. And so that certainly will work. But yeah, you wouldn't normally do a host because that actually exposes that host to the rest of the world. Now, dynamic NAT is where it assigns a public IP address from a pool of addresses to each packet that originates from a device that has a private IP address assigned when that packet is destined for a network outside the company. So addresses are assigned on a first come, first served basis. And so again, this is still it may be dynamic, but it's still a one-to-one relationship. And so if you've got 16 external addresses that are available in this pool, only 16 hosts can talk to the rest of the world at any one time. So we haven't actually, well, I suppose the assumption with this process is that not everyone's going to be talking on the internet all the time. Now, that's, of course, not particularly practical these days, but yeah, that's basically how it's designed to work. And so when one host finishes with that global address, it will then be available for someone else to use. Now, there is a plan, is where we, and I think one of the introductory slides spoke about how one public IP address can be used, shared by thousands of hosts. And so that is actually, at least Cisco itself doesn't call that NAT, it calls it PAT, which is port address translation. And so basically, they've just sort of extended it up a layer, and so we actually use port numbers as well to identify conversations. And so the beauty of this is the plan that allows you to share one public IP address amongst possibly thousands of internal addresses. And so, as I said, it uses port numbers to track the session. And so when you look at your NAT translation table with PAT running, you'll notice that it's got inside global, inside local, and then it actually lists ports. Now the port number needs to be unique in this column here. So if two internal hosts are actually using the same port number, it will actually have to change one of them just to make it unique. So we'll actually have to rewrite the TCP header as well if that's required. And so of course outside local and outside global are again the same as per normal. And so it will translate the source with a packet outbound. It will actually translate the source address from the inside local to inside global. It will also possibly change the source port number as well, just to maintain a unique number. But of course that's the router doing it, so the inside host doesn't know that it's happened, and the server that's communicating with doesn't actually know that that's happened as well. So it's all transparent. And so as you can see, you just need to keep track of more conversations, or more details for each conversation. So PAT tries to preserve the original source port number, but if that port number is already in use, PAT will assign the first available port number for the appropriate port group. And so when there are no more port numbers available, PAT moves to the next public IP address pool if there is one. And so looking at the address translation table, you can see that the same external address is used as your inside global, but it will have different port numbers to maintain the uniqueness of the connections. And so here they've actually got two hosts using the same internal source port number, and so it actually had to rewrite this one. I'm assuming was the second one that went through. Now, how do we compare NAT and PAT? So static NAT translates addresses on a one-to-one basis. Dynamic NAT also does it on a one-to-one basis. It's just temporary as opposed to more permanent with static. PAT uses port numbers so that one public address can be used for multiple privately addressed devices. PAT can still function with a protocol such as ICMP that does not use TCP or UDP as well. So what are the advantages of NAT? So the whole reason that was designed was to conserve your legally registered addressing scheme, and so you can save a lot of public IP addresses. It increases the flexibility of connections to the public network, so with multiple NAT pools, backup pools, and load balancing across NAT pools. Provides consistency for internal network addressing schemes. You do not have to readdress the scheme if a new ISP or public IP address is assigned, so that saves a bit of work. And provides network security, hides user private IPv4 addresses. And so, especially with PAT, it actually only makes that translation when a conversation is started from the inside of the network. And so it's basically all the firewalling you get at home is actually NAT. Now, there are some disadvantages as well. And so performance is degraded. As I said, there's some overhead for that router. It needs to do stuff. And so it needs to rewrite at least IP headers and probably TCP headers as well. So when you do that, of course, you need to calculate checksums and and so end-to-end functionality is degraded. So translation of each IPv4 address within a packet header takes time. And then there's end-to-end traceability. So some applications require end-to-end addressing and cannot be used with NAT. Static NAT mappings can sometimes be used, and troubleshooting can be more challenging. Tunneling becomes more difficult as well. So initiating TCP connections can be disrupted as well. So it's not all positive. There are problems with NAT, and that's why this was the quick solution, but of course IPv6 was the long-term solution. Okay, so how do we configure NAT? So we're going to talk about static NAT first. And so there is a command called IPNAT, and then basically we do an inside translation because we're talking about an inside, we're talking about the inside network. And so IPNAT inside. And then you do, so you do IPNAT inside source static, and then you do your private IP address or your inside inside local and then inside global. And so that's how you get your one-to-one relationship. That's great. That's your NAT translation done. But now you need to tell the router what interfaces are inside and what interfaces are outside. And so normally you would only have one outside interface. That would be the one that goes to your ISP or your upstream provider. And then you would have however many internal interfaces on this router, depending on the size of your network. And so you do IPNAT inside for all of those interfaces that are on inside network, and you do that IPNAT outside, typically on the one interface that's on the outside. Now, for all types of NAT, you actually need to do this. It sort of orients the router, that then understands basically what's inside, what's outside. It needs to know that. Okay, so here's an example. So you need to do I suppose one thing I didn't say about that is all active interfaces need to be configured with IPNAT inside or IPNAT outside on that particular router. All the other routers don't need to know because they're sort of, it all happens transparently to them. Okay, and so we do our IPNAT translation. So here we've got an inside local address of 192.168.11.99, and the inside global address assigned to that server is 209.165.201.15. And so that's what the rest of the world will see. If someone wants to hook into your web server through your NAT translation, they actually either pod in that IP address, or they have a DNS entry that translates to that IP address. And so, of course, you need to configure your interfaces, but then you also, that's really not to do with NAT. But of course, you do need to do IPNAT inside for serial 000, because that's on the inside half of the network. And for 010, you need to say that that's the outside address. And so that's an example of how you configure static NAT. All right, so how do we analyze it? So a client opens a web browser for a connection to a web server. The router 2 receives the packet on the outside interface. So we're talking about a statically translated address like the previous slide. The router 2 receives the packet on the outside interface and checks the NAT table. And so then replaces the inside global address with the inside local address, because it's coming into your network. And then it will forward it onto the network, and of course the web server will receive it. So the web server, of course, will respond, and so on the way out, it will then translate the inside local address to the inside global address as being the source address. Of course, it was the destination address on the way in. And so, of course, it uses this table here. And, of course, it will be routed through the internet and get to the client if all things going well. So how do we verify static NAT? And so basically, I show IPNAT translation. Now the top one here is just showing that you've got a translation sitting there waiting. But if someone actually connects, that is you'll actually get that line still stays there, but it actually shows you that we have an active conversation using that translation at the moment. Now you can do show IPNAT statistics to see how many translations are going on. And so you can see that we've got one static translation, no dynamic, and no extended. And so it's all going well, but no one's connected yet in this one. And so here, after we've had a session happen, we've still got one static translation. Peak translations are 2, and so that's 1 and 2. So we've actually had 5 packets that have been hits for that translation. And so, of course, you can clear IPNAT statistics, especially if you're fiddling around with NAT, reconfiguring it. You might want to, as soon as you finish it, you might want to clear your NAT statistics just so that you can see what's happening with your new setup. Okay, so dynamic NAT is another, of course, is an option. It's not regularly used these days, but it is an option. And so for dynamic NAT to happen, you need to have a pool of public IP addresses. And so again, how do we configure it? So it adds extra steps, because you actually have to create the pool first. And so, funnily enough, the command is IPNAT pool. You can give it a name, and then from there you specify the start address and end address of that pool. So the first and last addresses. Then you can supply either a net mask or a prefix length as well. So that just defines the pool. Now, because it's dynamic, and I think I might have hinted at this a couple of weeks ago, you actually need to have a list of internal addresses that are allowed to be translated. And so this is where you use an access list. And so access list 1, permit, and then the range of addresses. And so you might actually need to have more than one line in this access list if you've got a fairly complex addressing scheme. That does depend if you've got lots of subnets. But yeah, so basically permit, and then you would do the network number, and then of course the wildcard mask to define the range of addresses. So basically they're the two sort of starting bits of information. What are we using for inside globals, and what are the valid inside locals? Then we need to tie it all together, and so we use the IPNAT inside command, and so that we do inside source, and then we use list. If we call this access list 1, you do list 1, and then pool, whatever you name this pool. And so that ties it all together, saying we've got this list of hosts, and they can use this pool of addresses. Cool. And then, of course, again, because we're doing that, you need to orient the router, tell it what its inside interfaces are and what its outside interfaces are, or interface. So here's an example. And so we do IP NAT pool, give it a name of NAT pool 1. How imaginative. And so this is the first address there. So 209.165.200.226 all the way through to 209.165.200.240. And then we have a net mask of 255, 255, 255, 224. And so that's the inside global addresses that are available. And then again, as we said, we have this access list, number 1 as per normal. And so of course we need permit, saying, hey, these are permitted to do it. And they do 192.168.0.0.0.255.255. So basically any 192.168 address will be allowed. Now that's very accommodating, I suppose. We do have more than one subnet, so it certainly will cover those 2 subnets. You could have done 2 lines, 192.168.10.0.0.0.255, and then the next line could have been, of course, 11.0.0.0.0.255. So that would have been more precise, but of course, if you added another subnet later, you'd have to modify the access list as well. So we've got the pool, so we've got the inside globals, we've got the inside locals. Now we've got to tie them together, and so IPNAT inside source list 1, so access list 1 here, pool NAT pool 1, and so to the name there. So that's tied them together, and of course you always need the IPNAT inside, IPNAT outside. So that will do it. Now, how do we analyze that? Basically, of course, now with static, of course, often it's outside communications talking to a server. But of course, with static NAT, that server can also connect to the outside world as well. But with dynamic NAT, because we need to be a valid, a permitted inside local address, these connections will always be initiated from the inside network. And so, as you can see, we've got this 2 addresses here from the pool being used. So we do show IP NAT translation. And so they're all both talking to the same server by the looks of it. So the source address starts as 10.10 and 11.10, and it ends up being these 2 addresses here as the source address. So of course the server's able to reply, it's all good. So of course the translation will happen the opposite direction on the way back. Okay, so how do we verify it? Again, show IP NAT translations. And so you can see that these are the translations that have happened. You can do show IP NAT translations verbose, and it will give you a little more information. And so it actually just tells you the time that it started and when it closed the connection. There is clear IP NAT translation star. You might actually need to do that if you maybe reconfigure your IP NAT translations. I think you actually need to do that before you can reconfigure it actually. And so, yeah, that's a way you can clear translations if you're reconfiguring. So we've got clear IP NAT statistics, and then you have them connect, and then you can see that you've got 2 dynamic translations happening, and yeah, so we've had 24 packets hit with that, and So we're using NAT pool 1, and so 2 have been allocated. Okay, PAT. Now PAT is actually not greatly different to that dynamic we used. It's just that there's two options. Because with PAT we can actually use either a pool, or we can actually just use your outside. You can actually just share the interface of your outside interface. You can share the IP address from the outside interface. So IP NAT pool, start or end, net mask. So there's actually no great difference there. Access list, again, is actually identical what we did with dynamic NAT. You know the only difference between the two is you actually just put in this word here called overload. So that in one of the earlier slides it said sometimes PAT is called NAT overload. That's because that's the extra bit of the command that you throw in. And so this is actually identical to what we did in that previous example, except for this one word. And so again, of course, you need to always do the IPNet inside and IPNet outside. So an example, so we're defining the pool here from 226 through to 240. That's identical to the previous example. Again, we've got all of the 192.168 addresses permitted to be translated. Then we use the IPNet inside command to tie it all together. So source list 1, pool NAT pool 2. Oh, we've called it NAT pool 2 instead of NAT pool 1. But we've got that extra word overload. And again, IPNet inside and IPNet outside. And away it rolls. And so that was using the pool of addresses. And so if you've got absolutely thousands of hosts going through, you might actually need a pool of addresses. But if you've got only up to 1,000 or 2, you can normally get away with one address. So when a public address is assigned to an external interface on a border router, that public address can be used for PAT and translate internal private IP addresses to a public IP address. So this way of configuring here is the same as what your router at home does. And so you still need an access list to define who the valid inside local addresses that are allowed to be translated are, but you don't need to define a NAT pool because we don't actually have a NAT pool. We're just using one interface address. And so basically you do IPNet inside source list, access list 1 has been the one that we're doing regularly, but instead of saying pool, you actually say interface. And so if it's S010, you'd actually just put S1010 there, and again overload to make it PAT. You always need IPNet inside and IPNet outside, and so away you roll. So analysing PAT, and so of course we're using the scenario we used before where they use the same source port, these two different hosts. And so your inside local address is this, it gets translated to this inside global, and this one's had its source port maintained. This one, of course, has this address translated to the same inside global, but can't use the same port number as that. You've got to be able to figure out, you've got to be able to keep these things unique. And so the source port's changed to 1445. And so it will work nicely. Of course, when it comes back, the router, of course, will change that 1445 to 1444 as a destination, and it'll work nicely. Which, of course, what it's talking about here is it comes back with a destination address that will be translated back to from the inside global to the inside local, and the destination port will be translated back to what the host originally used. So the host won't even know it's happened. How do we verify it? So show IPNet translations starts using these port numbers as well. So it shows you extra information. And so inside local, inside global, outside local and global, of course, are identical. And so you can see that there's two dynamic, but they're There are two extendeds as well. And so it shows you that we're using the NAT pool. Only one address is in use at the moment. And so away it rolls. Now, port forwarding is sort of like a static PAT as opposed to static NAT. So when we looked at static NAT, that one internal server used one address. It was a one-to-one relationship. And so if you've got a server that has lots of services on it, that would work brilliantly. But that's less and less common these days because a lot of us use VMs to do a specialist job for many things. And also, I don't know, if you're using Windows, there's more and more things that actually can't coexist on the same server anymore. So you often have different hosts doing different jobs. And so basically, that static NAT, you'd end up needing quite a few external addresses to do it. Or you can do port forwarding. Now, of course, port forwarding is an option on your home router as well, often. And so basically what that means is when a packet arrives with a destination port of X, let's just say port 80 for a web server, instead of the web server, the router responding to it, will say, why don't you just forward that to this internal host? And so it will translate the addressing from port 80 as a destination, and it will send it to your web server. If it's coming in as a port 23, well, it'll go to a telnet server now. Hopefully not doing that these days, but anyway. FTP, of course, is another option. And so basically, port forwarding allows an external device to reach a device on a specific port number, and the device is located on your internal network. Required for some peer-to-peer file sharing programs and operations such as web serving and outgoing FTP. Solves the problem of NAT only allowing translations for traffic destination for external networks at the request of internal devices. And so basically, if you've got a mail server at home, you can actually do a translation. Now, of course, people have got to know your IP address. That can be a complication, but there are solutions for that too. So, and so this is showing a more home router solution where you have someone connects to port 80 externally. Typically, you would also have it internally as port 80. TCP, of course, is what HTTP uses. And so we've got a server IP address of 192.168.1.254. And so some external client connects to port 80. Of course, without this, it would normally that would often open up your configuration page on the router. That's not necessarily desirable if they're an unknown person. But of course, if you've got a web server that you do want people to connect to, this can be a solution for that. Now, how do we configure it? So that was, you normally have a port forwarding, single port forwarding as an option on many of your broadband routers at home to be able to do that. And that will work quite nicely. You are better off with a DNS name of some sort, but there is actually dynamic DNS options about that you can do that. Now, so you can do that here as well. So IPNAT inside source static. Now, so it's looking a bit like when we did static NAT before, but because we put TCP in there, oh, okay, we're doing port numbers as well. And so you're inside local 192.168.10.254, port 80, and then translate it from the 225 address, which is the one that's on serial there, to 8080. Of course, you still need your IPNAT inside and IPNAT outside. So that is certainly a possibility. So again, because it's static, it will show up with this blank line. We're using 8080 apparently. On the outside to 80 on the inside. Yeah, that wouldn't happen all that often, I don't think. But anyway. And so that's the static entry, but of course someone is actually connected, and so it will actually show you this entry as current conversations going on. Now, NAT for IPv6, it is certainly an option, but it's not something you'll do often. And so IPv6 was developed with the intention of making NAT for NAT unnecessary. So it was, as I said, it's the permanent solution to IPv4 addresses disappearing. But it does have several forms of NAT actually, and IPv6 does have its own private address space. So basically, there is a range of the IPv6 range called unique local addresses. And so it's very similar to the private addresses from IPv4. And these cannot be routed on the internet, the same as private IP addresses. And so basically, you've got a range of FC00 through to FDFF set aside for those. And so that's quite a few networks that are available. And so basically from there, so this is /7. So from that, it actually gives you a lot of options. And so of course, you've got from /7 all the way through to /64 to make unique addresses with. And so, of course, from there, you've got the 64 bits for your host address. Allows sites to be combined without address conflicts and allows internal connectivity. Not routable on the internet. So there is a private addressing space in IPv6. Now, there is NAT for IPv6 where you can actually have access between IPv6 only networks and IPv4 only networks. So not translating private addresses to private addresses. So basically, how do we get that to happen? So dual stack is the most common solution these days, where you have both an IPv4 and an IPv6 address on many things. But if there isn't dual stack all the way through the network, you can actually tunnel through. And so typically, of course, it's going to be the IPv6 that's not everywhere. And so you can tunnel IPv6 packets inside an IPv4 packet. And so there is NAT for IPv6. And it should not be used as a long-term strategy. Older network address translation protocol called NATPT. For the protocol translation, that's not done, but there is NAT64, but I don't think we're going to be talking a lot more about it. No, we're not. So yeah, you won't actually see NAT for IPv6 very often at all. Okay. So how do we troubleshoot NAT? So of course there's the show IP NAT translations, which we've looked at a lot. You can clear the statistics, you can clear the translations, and that's nice. But of course there's also debug IP NAT. There's a few options for that. And so that will show you events as they happen. And so that's also useful if you're having trouble with NAT. And so there's IP NAT or IP NAT detailed. And so it will just show you translations as they happen. So there are some symbols you can see there. So the star means it's occurring in a fast switched path. So in other words, we've got Ceph running, or Cisco Express Forwarding. Of course, S means source address. ABC to WXYZ, of course, is your translation. Then you've got your destination addresses as well. And you can check the ACL. So that shows you that information. So if the right translations aren't happening, you can actually check your ACL to make sure the correct private addresses are in there. So show access list is a good plan for that. So internal hosts cannot contact external servers. And so show IP NAT statistics. We've got zeros everywhere. So things aren't good. So there's outside interface S000. That looks like an inside interface to me. An inside interface of that, someone's got it around the wrong way. And so yeah, might need to fix that. And here we've got an ACL 192.168.0.0. We've got 0.00255, and so, well, we don't have a 192.168.0. We've got 10 and 11. So you either need to modify that to have a 10 and 11 line, or you need to add another 8 bits to the don't care part of the wildcard mask. And so, of course, their solution is that. So the summary. We've looked at how NAT provides IPv address scalability in small to medium-sized networks. We've looked at how to configure NAT services on an edge router, and we've also looked at how to troubleshoot these things as well. So it's all good. One more chapter to go, chapter 10. I'll see you soon.